Today we're going to be talking about designing security solutions and having everything all built in from day one. So Dale, talk to me about what secure by design actually looks like.
Yeah, secure by design is taking a very deliberate approach to building security at every layer of a solution rather than just going, oh, I'll just try and buy a security product and layer it over the top. So it starts from foundational levels of looking at what your network needs to look like, what your servers and services need to look like, what your users need to do, how they need to attach to a system, what the intervening componentry needs to look like, and being very deliberate with the choices that you make based on the customer's risk profile, their business scale and scope, what their operational requirements are, what their financial requirements are, and layering that all together in a single design that ultimately is secure because each of the underlying components is inherently secure in its own right.
And we've talked a lot about, knowing what you have and going back to the basics as being really, really important. In this scenario or this context, why is the fundamentals so crucial?
Look, great question. And it's like, probably the easiest way I can explain this is it's like building a house. If you don't have the foundations of your house right, it doesn't matter how good it looks. It doesn't matter what expensive equipment you put inside it. If the foundations are not right, it's going to fall down. It's not going to last as long. It's not going to be secure. It's not going to withstand a storm. IT solutions are exactly the same. If you don't have the foundational design correct, if you haven't built based on true business requirements, or you've made too many assumptions that are not grounded, then your solution will never be secure. It will never deliver what you want it to deliver, and you'll always be chasing your tail about why isn't this working as well as I wanted it to. So designing for security or secure by design, foundationally is just good design practice for IT solutions. And again, it comes down to being very deliberate about the choices that are made at every level of the solution itself.
And extending on that building a house metaphor, obviously if you don't have the correct tools, you can't build a very successful house either. So the sort of tools and equipment that are needed to design a secured network, what does that look like, or what does that include?
Look, again, great question. The things that you need to be looking for is, do I actually understand what it is the outcome is that I'm trying to achieve? So am I trying to build a 1-bedroom flat, or am I trying to build a 5-bedroom house, or am I trying to build a 15-bedroom Hollywood mansion? Understanding very, very thoroughly what it is you're trying to achieve is important, and then making sure that you understand the scale of it and what the requirements are in terms of how fast it needs to run, how long it needs to run for. Is it going to be running in an environment that is hostile? Very big difference between, say, running an office-based solution or running a solution that needs to work in a manufacturing facility where it could be 80 degrees 95% of the time, or maybe even a mobile solution that has to run on the back of a truck. All of these things need to be considered, and they need to be designed for, and then also look at what could happen outside of the design and whether it needs to have 99.9995% uptime, or whether near enough is good enough. All of these are considerations that go into the design. Then when it comes to the tools, it's about selecting things that are appropriate for the environment and appropriate for the requirements. It's no good going down to your local big box store or your local Officeworks store and going, I need to find something that's going to run 99.9% for the next 10 years. You won't find it there. It's a specialised piece of a kit, and you've got to find somebody who actually stocks that. And that primarily is the difference between what you would consider as a residential or domestic grade appliance, which is designed for near enough is good enough for the next 5 years, versus enterprise grade, which is, I need 10 years out of this and it's got to run 24/7, 99.999% of the time. So, the old adage, if you get what you pay for, is very much the case when it comes to IT solutions, particularly where the requirements are quite extreme about your uptime and your reliability.
And so one of those particular tools for obviously security specifically, is looking at role-based access controls. For people who have no idea what that means, just run us through like what it looks like and how it's supposed to work in practice for security.
Yep. So I'm going to go back to the whole house analogy. A role-based access control would be, in a normal household, you'll have parents, you'll have kids, you'll have extended family, you might have a cleaner, a gardener, a maintenance person. All of those people have different requirements for what they need to access in the house, how they need to access it, when they can access it, and when they're actually in there, what they can actually do. Role-based access control within an IT sense is exactly the same. You're going to have different roles that people perform, and those roles are going to have different levels of access to different components of the system. So some of it might be your role, let's say you're an accounts clerk. Your role would be that you're allowed to enter financial data, you're allowed to read financial data, but you may not be able to modify financial data. So that would be a role with a specific set of conditions around what you can do. You might be the finance manager, which means you can read, you can report, and you can change, but you might not be able to enter. Okay, so a role is a specific set of rules, if you like, that govern what you can do once you're actually inside a system. And those roles can be as granular or as coarse as you like, but ultimately they're a set of rules that govern what you can do once you're actually authenticated with an IT solution.
And how do we manage that? How do we get them authenticated through? Is there like a particular system that we use to do that?
There's a number of different systems that handle authentication, and authentication is a little bit different from authorization. Authentication means you've been able to validate who you are, and you are who you say you are. And that's generally handled by, maybe Entra ID through the Microsolve suite, or through Google Workspace on the Google side of things, or perhaps even an internal file server. Once you've actually validated who you are, then you go to the authorization step, and that's the bit where it turns around and looks at the roles that you're actually allocated to your position or to your user, and then what those roles actually give you access to, which could be a certain application, it could be a certain folder or group of files, it could be a certain function within an application. It could even be something as simple as you don't have internet access for your particular role. So it's quite varied, and it's quite configurable as to what you do within those roles.
And so we're also looking at zero trust and how we change that from just a throwaway buzzword and into something that we can practically implement for organizations and for staff specifically.
Yep.
So how do we do that?
So look, I guess first and foremost, zero trust is a concept largely. And what it essentially means is you don't trust anything, you don't trust anyone. You take an approach that anything that tries to attach to a network or connect to a service or a server or an application is, you don't know anything about it. So even though that person might have come inside your building and plugged into your network, you look at it and go, I've never seen you before, I don't trust you. So that's zero trust. So you trust nothing, and you validate everything. So the whole point of that is if they come in with their laptop from home, you look at that and go, I don't know what that laptop is. Mr. Laptop, you need to prove to me that you are well protected, you've got the latest patches, you've got the latest antivirus, and the person using you can actually validate that they are who they say they are. So you don't assume anything. So it's all about being very, very deliberate about what you allow to happen in your environment. So that's the basis of zero trust. So it'd be like a tradie turning up at the front door of your house and going, hey, I'm here to fix the roof, and you look at it and go, I didn't even know I had a roof problem. First thing you're going to do is, I don't know who you are, stop, show me some identification, show me that you've got a work order, show me that you're appropriately qualified to do the work, now show me what you're actually supposed to be doing, and I'll see whether I actually want that to happen. So that, in a nutshell, is what zero trust in an IT perspective it is. We actually know what it is, we just call it different things.
And so how can we work with organisations and with staff so that they don't get overwhelmed by all of these, policies or changes that we need to implement in order to be safe and secure, when it's just easy to go, oh, well, we all have the same password or the same device, so it saves time?
Look, there's always been the argument of accessibility versus security, and you know, you can't have one without the other. I challenge that to say that a well-designed, well-architected system with appropriate security is actually easier to use than one that doesn't have. You know, if you've gone through the process of actually defining your roles and understanding what a role gets you access to, it actually makes your system easier to use, and you can actually trust the data in it far more than you can with a completely open system, because you actually know exactly who can make what changes to what pieces of data in what parts of the system. So that approach actually makes things easier. And the ideal computer system is frictionless, it's almost invisible, it just does its job, and you're able to walk up, do your job, walk away, and it's done, and everybody knows that it's done.
Beautiful. Well, thank you so much for your time. If you have any thoughts, questions, concerns, don't be afraid to reach out to us. Check the description below for some more information, and make sure you reach out. Thank you.